Alright, so welcome to chemistry class. We're going to look at unit 4 or topic 4 in other words. Topics: atoms, elements, mixtures, compound, and and molecules. Alright, so we're going to look at the structure of atom. Structure of an atom. So we need to know what an atom is. What is an atom? So an atom is just a simplest particle of an element that can take part in a chemical reaction. Or in other words, this is simply the smallest particle or the basic building block of matter. In other words, the basic building block of matter. That's what we call an atom. So an atom has many things. Number one, an atom it has shells. Number two, it has the nucleus. Then number three, protons, neutrons, and electrons, and the like. Then another thing you need to know is the structure of an atom. So that is the structure of an atom. That's how an atom should look like. So we have the electron there, we have the shell there, we have the proton there, and the neutron there. So an electron this is just a negative charged particle. Then the shell is just simply the energy level. In other words, it's just the path at which the electron orbits. Then protons, these are just simply positive particles in the atom. The neutrons are neither negative or positive. They're just neutron. Alright, so we move on to another concept we need to look at under this topic, which is what we call the nuclide. How do we identify an element on the periodic table? So what you need to know is that just get my Alright, so another concept you need to know is how you identify an element, or how an element is represented on the periodic table. For example, you have element A here, right? So we have normally you're going to have a figure on top there. We're going to say it is Z. Then at the bottom there, we're going to say it's what? X. So Z simply represents what? The mass number. Then X, atomic mass number. Then we move on to the next concept to look at, which is what? An element. We need to know what an element is. So what is an element? So an element is just a pure substance which cannot be split into two or more simpler substances by any chemical means. So an example of elements we have aluminium, calcium, and iron, and the like. So we move on to another concept which you need to look at. We're going to look at a mixture. What is a mixture? So a mixture, this is just simply a substance which consists of two or more elements that are not chemically combined. Examples of a mixture: we have air, brass, bronze, mold. All those are examples of of a mixture. The next concept we need to look at is what we call a compound. What is a compound? A compound is a substance that consists of two or more elements that are not chemically combined. Examples of such we have water, common salt, and the like. Then we move on to the next concept is what we call the a molecule. We need to know what a molecule is. So what is a molecule? So a molecule is simply the smallest particle of an element or a compound which exists independently, that is in a free state. So molecules can exist in three types, or in three groups. Number one is what we call the monatomic molecules. These are just elements that exist as one. Then we have what we call the atomic molecules. So these are molecules that exist which cannot exist on their own. They need to have they need to exist in pairs of two. That's when they can exist. Example of this we have oxygen, hydrogen, nitrogen, and chlorine. Then the other concept we need to look at under this topic is what we call isotopes. So what are isotopes? So isotopes, these are just simply Isotopes are atoms of the same element having the same number of protons but different number of what? Neutrons. Isotopes are the atoms of the same elements that have the same proton number but different neutron number or mass number. So examples of elements that have isotopes: number one, of hydrogen. Isotopes of hydrogen 1, hydrogen 2, hydrogen 3. Symbol H, D, and T. Nuclei represented by this. Their masses and their number of particles is presented there. Alright, so we'll look at the similarities of among isotopes. So number one, they have the same atoms of the same element. Number two, they have the same number of protons. Then we need to look at the differences between what isotopes. For example, like this carbon 12 and carbon 13. What is the difference? So number one is that they have different mass numbers. Then number two, they have different neutrons numbers. Then physical properties, they have different physical properties. Our chemical properties have the same chemical properties. Alright, so the uses of isotopes. Number one, hydrogen isotopes are used in the study of nuclear energy. Then uranium-235 is used in the manufacture of nuclear weapons. Then carbon-12 isotope is used in the radiocarbon dating of machines to determine the age of fossil fuels. Alright, so another concept we need to learn is how do you calculate the relative atomic mass. So we need to know what is the relative atomic mass. So relative atomic mass of an element, just simply given the percentage abundance of isotopes and form mass spectrum is defined as the sum of products of percentages and their masses. So this is a definition right here. This is a perfect definition. The sum of products of the percentages and their mass numbers. So we need to know the formula as well. So the formula, how do you write the formula? So this is the formula. So formula A is equals to what? If you are given an isotope, you need to know what is atomic mass number and the percentage they will always give you in the question, and you need to divide by what? By 100%. If you have more than one isotope, then you repeat the same thing, but you choose different mass numbers. So let's look at, for example. Here we have chlorine. Chlorine has two main isotopes, chlorine 35 and chlorine 37, with abundances of 75% and 25%. So how do you find the relative atomic mass number? Simple. So we need to multiply this atomic number or this isotope with this with this percentage here. So we're going to multiply 35 by what? We're going to multiply 35 by 75. Why? Because 35 is atomic mass number of chlorine isotope. Then 75 is what? Is the percentage abundance. That's why we have multiplied 35 and 75. Then of course you need to divide by 100. So you do the same thing on the second isotope. You multiply this 35, which is the atomic mass number of that isotope, with its percentage abundance, which is what? Which is 25. So when you do calculation properly, you should get something like this. So here is your exercise. You can attempt question 1 and leave a comment in the comment section. Then I will definitely mark your work.